Hello, and welcome to the OpenCV.AI for Entrepreneurs podcast. My name is Anna Petrovicheva, and today I'm going to be talking with Professor Daniel Cremers from the Technische Universität Münche, one of the most prominent researchers in computer vision and artificial intelligence areas. Hi, Daniel, and again, it's a pleasure to host a podcast at OpenCV.AI for Entrepreneurs with you.
Hi, Anna. It's a great pleasure to meet you.
Thank you. So my first question would be about your path in artificial intelligence and computer vision. Could you please tell us how you decided that this will be the field that you would focus your scientific research on?
So that's for me, it was a long journey to come to computer vision and artificial intelligence. I started actually in physics and mathematics, quite honestly, because that was from high school, the topics that I was best in. The other topics I was just not so strong in. And so that attracted me to that field. And also this desire to somehow understand the world and be capable of, modeling it like they do in physics. And I was very happy in physics, but there was one thing that disconcerted me, is that by and large in research in physics, people would work on topics that have almost nothing to do with everyday life. You would be working on quantum mechanical models or on string theories. And I remember for me an eye-opening moment was when I came home during my master thesis in quantum chaos, and my mother said, "So Daniel, tell us, what is your master thesis about?" My mother has no physics background, so I said, "Mom, do you really want to know?" And then she said, "Well, why don't you give it a try?" And so I said, "Okay, right now I'm computing these energy levels of this hypothetical quantum mechanical system to see how chaotic behavior arises in quantum mechanics." And then there was just dead silence in the room, right? And my mother didn't know what to say. And then at some point she said, "Well, as long as you enjoy it," right? And then I realized, no, that's not all. I do enjoy math. I do enjoy, sophisticated mathematics. But what I wanted to do things that impact our world, that have an effect on everyday life, on people. And I should say the first thing I wanted to go into is into neural networks. I was fascinated at the end of my physics studies with neural networks. And so I even sent an email to Geoff Hinton saying, "Geoff, would you be interested in taking me as a PhD student?" He didn't respond, and other people did respond and said, "Look, you seem young and smart and talented. Why do you want to do neural networks? That's a complete dead area," right? This was the end of the 90s we're talking about here, right? So I said, okay, I thought this would be fascinating, but if you all tell me it's a dead end. So I actually didn't listen. I did go into neural networks, but in biology. So my first, PhD was in the neurosciences. I started a whole year working towards a PhD in neural computation and modeling the visual pathway of mammals. But then for some reason, the project didn't move on quickly enough. Maybe I was too young, too impatient, and I decided to switch. And I dropped all of it after a year and then went into computer vision. And I must say that topic has fascinated me from day one. And I remember the people who fascinated me were my then advisors, Christoph Schnörr, and in particular also the papers of Joachim Weichert on anisotropic diffusion for image processing. And for me to see, sophisticated mathematics do things to images and process them and, remove noise and enhance structures, for me, that was just fascinating to see. And I think that fascination has never lost me until today. It's still very strong.
Wow, it's a very, very interesting path. I specifically enjoy. So probably when neural networks, again, like there was a rise of neural networks in 2012 and later, were you able to somehow, understand more about how they work inside, because you know how the neural pathways in mammals works inside. So it's a very good combination.
Yes. So one of the first things that this, I must admit, after the 1 year in the neurosciences, At first, I thought it was a wasted year, but very quickly I realized not at all. And this is my recommendation also to young talents who are going into, research careers. Even if you do detours, these are not wasted time, right? You learn a lot, and this is often complementary and can help you later on. And exactly, you raised that question. What did it help me when neural networks came back in 2012 and subsequent years? The first thing that I realized is that the neural networks that we tend to use in vision are very, in many ways, different from biological neural networks that are often much more complex, much more sophisticated. For example, in computational challenges in vision, we typically use feed-forward networks. Now, increasingly, recursive networks are also coming into play, but in the visual system, the networks we have there are much more sophisticated. Starting with more spiking type neurons with Hodgkin-Huxley equations that govern the spiking activity of a single neuron, and then also significant feedback loops that we have in the visual pathway, which are to date still not fully explored and understood even in mammals. And so I think there's a lot more in biological neural networks that we can possibly include in computer vision.
Yeah, I was actually going to ask you about how you see the future of computer vision and artificial intelligence in, say, upcoming decades. So, what do you think would be the areas where we will focus most, right? Maybe some new types of data, some new types of algorithms. What do you think will emerge?
So one thing that I've definitely observed in my career in the last, say, 20 years of computer vision is that the topic of computer vision has become dramatically more relevant to society. When I started, a lot of my friends and colleagues, when they asked me, what is it you're working again on? I said, computer vision. They often had no clue what that was about and why it was of interest. And, admittedly, I've always been just fascinated with the topic of, enabling machines to see, to perceive the world like we humans do. And for humans, this is one thing I also learned from the neurosciences. The visual sense is one of the most relevant ones for us. So, for example, the cortex in mammals, in macaque monkeys, for example, 50% of the cortex neurons are constantly doing visual processing of visual information. So you could say, in some sense, we as mammals seem to dedicate 50% of our brain power to processing visual signals. And I think that says two things. It says, first of all, that these are very important for survival, for everything we do. But secondly, it says that it's not an easy problem to solve. Otherwise, we wouldn't dedicate that much brain power to the problem, right? And so that, I think, if you want to reproduce the capacities of humans in a machine, maybe building ultimately a robot, possibly even kind of copying the human, one of the most important challenges that you need to solve is the perception challenge, is making machines see. And obviously that doesn't mean just placing a camera, but actually processing the visual information that comes from that camera. And I think we've gone very far in the last 20 years, and some of the popularity we see now in computer vision, the growth in the community, it comes from the fact that we've actually achieved quite a lot, that now algorithms actually work. And I think some of it is because people put code online, like OpenCV was a great kind of contribution there to actually whatever actually works, put it there, make it available to the world, right? And that boosted significantly the performance of computer vision on real world challenges. And with that, the popularity of computer vision came about. And this dramatic growth where, every year the conferences are essentially doubling in the number of participants. When I organized ECCV in Munich in 2018. And when I set out to do it, I was expecting 1,500 participants because that was the number at the last conference, right? But that was very far from it. We ended up with 5,000 registrations. That's like a triple number of registrations from one conference to the next. Right? So this is a very crazy growth in the vision community, where all the seniors who are running these conferences still to date don't really know how this is going to pan out on the long run.
Yeah, totally. So I remember this ECCV. I was there in Munich 2 years ago when everybody traveled, unlike we do now. So yeah, it was a great conference, by the way. So congratulations on organizing it that well.
Thank you. Yeah, it was a lot of work, but I did enjoy it a lot, and I think it was a great. As I heard a lot of positive feedback, and so I'm happy people liked it.
Okay, so speaking about, I'm thinking about some new types of data that artificial intelligence is going to utilize in upcoming years. So I was going to ask you the following. So you did quite a bit of research in 3D and 3D space understanding. My feeling is that in the upcoming years, 3D data will become more like commodity than it is now because of emerging of devices like personal devices that have 3D capturing capabilities. So what do you think about that?
Yes. So I think in many ways the 3D world will become more will get more into focus for computer vision. As you say, it's not just more sensors that are available, like with the Kinect camera, RGBD sensors became really popular. The capacity to really at 30 or 60 frames a second scan at fairly good resolution 3D geometry. But what's also come into play is much more powerful algorithms to reconstruct the world from even standard cameras, and we've worked a lot on that, and many others have, advancing the precision and robustness at which you can track a moving camera, right? We're now at a level where we can track a stereo inertial camera system over, many kilometers, and even over 4 or 5 kilometers. The total drift in tracking it is maybe in the range of 1 or 2 meters, right? So the precision of these systems that we've been developing is significantly higher than anything we've seen before, the real-time capability. And so with all of these algorithms, we are now able to recover in very good detail the 3D world around us. And the main question, you mentioned it, the main question that arises here is to understand that 3D world, right? To distinguish, to measure similarity of 3D shapes, right? Even for humans, seemingly simple questions. I have 2 hands, would say they are similar, right? Well, how do you teach a machine to measure that similarity? It entails aspects of correspondence finding to figure out this thumb corresponds to that thumb, etc. And correspondence is arguably one of the nastiest computational challenges that we typically face in vision. Right? And so there's a lot of fascinating questions that revolve around shape, 3D shape, processing shape, analyzing shape, comparing shapes, measuring similarity, defining metrics in the space of shapes, and also things like interpolating shapes, right? If I see one human here, one human there, can I create a family of intermediate shapes? This all, humans are somehow capable of analyzing their world in this fashion. And I believe we need to make machines reproduce that capacity to understand not just planar images. That, I would say, it's not a solved problem, but we're close to it. With deep networks on ImageNet, we can processing, recognizing planar structure objects in planar images is a fairly solved problem, one can say, whereas understanding the 3D world is still there's still a long way to go.
Yeah, thank you. So my feeling also is that, in 2D space, many problems are now data bound. So as long as you have a very good data set, you are able to solve the problem in a very, very good way. But in 3D, we are still algorithm bound. we don't know how to solve the problems. So it will be exciting to see how it changes in the upcoming years.
So this is a good point. As you said, the data-driven approach became extremely popular with deep networks, and it's essentially if you have sufficient training data to cover the space that you want to work in, then deep networks do amazing things and achieve amazing results. But for 3D understanding, for 3D reconstruction, SLAM, to date, a lot of the deep learning-based approaches do not perform as well as classical, say, optimization-based techniques. And this is one of the most active areas in my team now, that we're exploring how to bring together the performance of classical optimization techniques in SLAM with this predictive power of deep networks.
Yeah. Exciting area to be in right now.
Yes.
Yeah. I also wanted to discuss the following. So my feeling is that unlike in many other sciences, we already touched that in software engineering and specifically in computer vision, many software and many papers are open source for free, available for free for everyone. So I wonder, what do you think, why software engineering and computer vision is so different in this sense from other sciences, where many papers are available on paid journals mostly, right? So paid journals are the source of the innovation, not GitHub or arXiv.
Mm-hmm. So this is a good question. I should say the other aspect that always attracted me into computer vision is that it was a very active community, with people from lots of different backgrounds who are very creative and who want to construct new things, and who are willing to change the world in many ways, and also willing to change how research is done, how research is communicated, and how research is made publicly available. For example, as you said, putting papers online is a standard. I've been in the vision community, and from day one, I've put all my papers on my webpage, and that was obvious. And sure, there are some publishing companies that at the time said officially I'm not allowed to do that, but then I figured, who's going to stop me, right? And in fact, yes. So I think the vision community just created facts, and I think it can serve as an example for possibly other communities. And this is not only about papers, but also publishing code, for example, right? This is very important for the reproducibility of science, that people can actually try your code and verify and validate the statements that you make in the paper. And obviously, this drastically accelerates research innovation, right? If people not only have to start from scratch every time, but they can basically build up on the codes that we make publicly available. So, for example, some of the SLAM algorithms that we've published over the last years, LSD SLAM or direct sparse odometry, we made the codes publicly available, and they have been immensely popular with thousands of people building up on them. And in addition, also data sets, right? If you look into, I was used to work in the neurosciences, as I said, it's super complicated there. And these are often also ethical issues that people realize they're facing, right? Because if you do experiments on a monkey or a cat, this is something that you should do as little as necessary, obviously, because you don't want to hurt any animals in the process, right? Or you want to avoid that. But in the neurosciences, someone records a data set. If someone else wants to do research, they have to record their own data set. Means they have to kill yet another mouse or a monkey or a cat or whatever, right? And so, these are serious ethical issues that come with not sharing the data that people acquire. Now, a lot of people in other disciplines tell me, oh, yeah, but what's my interest in sharing that data? I put so much effort into it, and now someone else can just download and skip that effort. What's my benefit in it? Well, visibility. In vision, you get a lot of visibility once you publish a data set. The ImageNet dataset, it's the best example. How much impact can you create by just releasing the dataset to the public? And if there's one thing that researchers are always keen on in an academic career is visibility, right? And impact. And this is a standard performance measure, and it encourages people to make data sets publicly available. And this is something that I try to, bring across to other disciplines so that they follow suit and follow the example that we set in the computer vision community of making things publicly available, because it advances humanity ultimately.
Yeah. One other thing that I think is very positive for computer vision community and computer vision development is that in computer vision, industry and academia kind of work together on advancing the state of the art, right? And it's great that many big companies and small companies also, they donate their studies and their data sets and their software tools to open source also. So my next question would be the following. So obviously there are positive sides of industry and academia working together in the state of artificial intelligence, but also obviously there are downsides, right? So the one downside is that right now in artificial intelligence, the salaries they pay is so high that many young people go to industry instead of maybe staying in academia and finalizing their PhD and staying in the university. So there are pros and there are cons to this collaboration between the industry and academia. What do you think is the best way for these two important entities to work together? How to work together so that it benefits both sides?
So this is, I think the interaction with industry is a good one, but it's important to structure it in a meaningful way. And as you say, the interests of industry in our field is great. It advances our field in many ways as well. But indeed, one of the challenges that you mentioned is that there is a certain competition when it comes to recruiting senior talents in particular. This is a problem that is becoming increasingly visible and that people take note of. The other day I had a very long Zoom call with our Chancellor Angela Merkel, and she wanted to know what are the challenges that Germany and Europe is facing in this age of artificial intelligence. And I said, well, for me, one of the biggest challenges from an academic perspective is how to retain the talents. In a time when industry salaries go completely skyrocketing, right? I mean, and at the same time, we in university, we have to offer fixed salaries. The German system doesn't allow me. Even if I had the money, I can't just offer someone more salary because it's all fixed and regulated. And so Angela Merkel took note of many of these points, and in particular of that one. And so there are now discussions of how we can improve on it. One way I think, though, to improve this is something I often tell my students now when they're moving on, when they get their PhD. I say there is very attractive opportunities in industry. The salaries are great. But one thing I've seen for myself is there is only so much money that you can spend in a lifetime, right? And when you work in vision and machine learning, you will always have enough money to live on. So this is not the concern. In the end, you have to ask yourself, what is it that what I want to achieve in this world? What is the thing that I want to leave behind? What is the impact I want to have on this world? And, I can just say from my own side, I realized that I don't need that much money. And what's the point of, this is a question my wife is often asking me is, well, what do you want to do with all this money that you make? I don't know, right? I mean, plus there is one other opportunity. If you really want to make big money, then startups are a great way to do so. And I have a lot of colleagues in the field who've shown amazingly successful examples of startups. Amnon Shashua with Mobileye, for one thing, or Michael Bronstein and Alex Bronstein. They're constantly creating new startups that often become quite successful. So, and I must say, if I have a choice, and I do, we all have, I'm a little bit more fond of startups because they give you even more freedom to really pursue the things that you think should be done in a way that is often not so easy in a bigger corporation, right? But that said, I think there is benefits to all of these career passes, and I think we should just be very happy that in computer vision, there's almost endless opportunities for everyone.
Yeah, thank you. Okay, so speaking about someone who is young, right? What would you recommend to someone who is only starting their career path or a scientific path in artificial intelligence and computer vision? What to focus on? What path to choose? Do you have some thoughts regarding that?
So, in terms of research challenges, I think there are many. And what I think, in fact, most important, I often get that question being one of the more senior experts in the vision community, where are the future challenges? The truth is, it's up to all of us to discover that, right? I mean, no one has the patent to know what the future holds, right? And I experienced it myself. I wanted to do neural networks and they told me this was a dead end, right? And I guess I should not have listened to the experts at the time, right? And there's many such examples through history. One of the most famous ones is Max Planck. When he wanted to go into physics, people told him, senior experts and leaders in the physics community told him, young man, you seem very talented. Physics, there is no open challenges. It's a solved problem. Why don't you go into different other disciplines? And fortunately for the world, Max Planck decided not to follow that recommendation. And so I think all these stories say that ultimately we have to, for ourselves, come up with our ideas of where we think the future lies. And I think that's important because that is the source of creativity in the community, that everyone has to develop their own ideas. And I think the community is already, humanity in general is far too much in the spirit of lemmings, right? Where one guy says we should all do graph cuts, and then the whole community does graph cuts. Then someone says we should all do deep networks. The whole community does deep networks. And I think there is room for more, independency to explore people's ideas. And I think this is important. Like for my lab, for example, sure, we work a lot on deep networks, but we also work a lot on many other topics. And most importantly, when I recruit young talents and they ask me, what should I work on? I tell them, well, you tell me, what are your interests? What do you want to do? And this takes time to develop one's own ideas, but it's really worth it. That said, I think for me, I have ideas where I think fascinating challenges lie. And I think one of the most fascinating challenges that is largely unexplored is how we can not just perceive the 3D world, but recover, a complete kind of simulation of the world. For example, we've developed algorithms where we can reconstruct an action in space and time, frame by frame, like say a rope jumping girl. But what we don't recover is the physics of the world. And this is something that I think where there's a huge discrepancy between human visual processing and machine visual processing. That as a human, let's say, this is something that's always fascinated me, even as a child. When someone throws you a tennis ball, it's amazing how in a fraction of a second you can put your hand somewhere and catch it, right? This capacity of a human to catch a tennis ball that someone throws at you, this has always impressed me quite a lot. I spent most of my childhood playing different ball games, soccer, volleyball, basketball, you name it, right? And I think one of the fascinations there for me was the capability of humans to predict the future and to extrapolate what's going to happen next, to the extent that we can actually catch a flying ball. It basically implies that on some level we can reproduce the physics of the world. We can predict how a ball is going to bounce off the wall, right? We don't need to reconstruct its position at every point until it reaches the hand, because that's far too slow. But, I tried it. Someone throws you the ball. If halfway through the ball flying, you close your eyes, you can still catch it, right? Not every time, admittedly, but many times, right? So, and I think this goes back to some capability of inferring the physics that governs our world, the mass, the momentum, etc., that governs the dynamics of the objects around us. And I think in computer vision, we've been far too much focused on reconstructing the geometry of the world, the surface of the object, possibly its albedo, its reflectance properties, but far too little effort has gone into recovering the physics behind the world, behind the dynamic world that we live in. And I think ultimately we need to move towards recovering the physics in order to make more long-term predictions of what's going to happen next. And this is yet another domain where humans excel. If I watch my kids, I have 3 small kids, and children are in many ways an inspiration, I think, for humans, but especially when it comes to visual processing, it's fascinating to see how they evolve from very early age on. They constantly watch everything around them, right, with an immense fascination. And it's very different. Vision algorithms, you have an algorithm that classifies airplanes, right? Give it an image, it says airplane, no airplane, car, dog, cat, right? But what does the human visual system do? When I see my kids look into the world, it's not like they just classify objects. No, they are trying to predict what happens next. And this capability is vital, obviously. The better I can predict what the line in front of me is going to do, the longer I will live, right? So clearly, this is a very important survival skill, the capability to predict the future. And this is yet another topic that I think is to some extent underexplored. Can we train deep networks to predict the future? And so I think there's a lot of fascinating challenges still to be explored. And for me, one of the inspirations is indeed the human. In the sense, not necessarily reproducing faithfully the neurons in the brain or anything like that, but reproducing the capabilities that the human system seems to have.
That's very interesting. So it's kind of related to. My feeling is that when we speak about the emerging industries and what AI made possible, right?
Mhm.
My feeling is that robotics is not where it should be, it could be, right? In terms of its impact in the human life, right?
Mhm.
And if we had this understanding of the physics of the world, robotics would definitely emerge way more than
Yes.
it has. Yeah.
Yes, so robotics is definitely an area that computer vision is very close to, especially when it comes to reproducing humans. And I think this is also an area that I've always been fascinated in, is how you can leverage perception to improve control and action. And so we've worked a lot on autonomous drones to do obstacle avoidance, etc. It's also a great test bed for real-time computer vision. And so indeed, the human is always an inspiration. I think it's always from day one been an inspiration for computer vision. And, even if in certain challenges like object recognition, we have by now surpassed the human capability of recognizing and categorizing objects. But still, I think the human is still an inspiration on many, many levels. For example, one major difference is when humans, process visual data, they use a lot of knowledge about the world. And how to bring all that knowledge into the machine is a challenge. Like we work a lot on autonomous driving, how we can get cars to drive autonomously, and it starts with reconstructing the 3D world in front of the car, and then autonomous maneuvering, etc. One of the key differences between machine and man is when I drive down the street and a ball comes rolling into the driving corridor. Well, I'm going to expect a child to come running after it, right?
Yeah.
Why? Because I know. Because I have world knowledge about what things typically happen in the world, which things are likely to happen next. And this is one of the things we need to reproduce in machines, the capability to predict what happens next. For driving assistance, this is vital. The longer I can predict the world into the future, the better I can avoid accidents and save lives.
Yeah, it seems that we have quite a lot of math and algorithmic studies to do in artificial intelligence yet, right?
Yes, yes.
So my next question is going to be about the research and how to keep up. So starting from the artificial intelligence boom, there was so many papers, so many different pieces of research and books, new startups, that it became really hard to follow follow what's really happening in the industry. Do you have some advice on how to do that?
So this is very tricky. I see that myself with the growth of the community, with thousands of people flooding into conference. The number of publications that we see surfacing per year is just growing dramatically to a level where it's hard to keep track of everything. Another thing that I notice is that the community is also changing with social media. For example, to date, I don't have a Twitter account, but I'm being told by all my colleagues that I should get a Twitter account, and so that in particular, for every paper we write, I can, Twitter it out into the world. But I'm still a little bit maybe old-fashioned, you could call it, right? Reluctant to believe that for being successful as a researcher, that you have to shout out louder, and who shouts the loudest over most social network challenges gets the most attention. To some extent, this is something I see today, and it disconcerts me a little bit. That my own PhD advisor once told me, once you put the paper on your webpage, people will find it. I'm not sure this is true any longer. If you don't put it on Facebook, Twitter, and whatever, people may not take note of it, right? And so in that sense, the world has changed a little bit, and it's a matter of, I guess, adapting to the new formats of communication, to blogging, to Twittering, all of these forms. But it still disconcerts me, because the question for me becomes, should I spend my time on research or on social media, right? Maybe it's better to write one paper and spend the rest of the time on social media rather than writing 3 papers and not having time for Twitter and blog and Facebook. I don't know, it's and
Preparing a video for YouTube, and yeah.
So this is tricky, but it's, overall I'm happy. I'm happy that there is so much interest in this area, so much activity, and especially over the last 20 years, seeing that area grow so dramatically has been quite a fascinating ride.
Yeah, totally. Okay, so my one last question would be the following. So what would you recommend to our audience in terms of reading about artificial intelligence? Maybe you have some sources, some maybe news leads, some maybe blogs, papers. Maybe your lab has some handle that we could follow on. Would you recommend something to our followers?
So that's a good question. It's a question that I frequently get, over the last 15 years of being a professor in computer vision. Generations of students have asked me, what do you recommend to get into this field? And it's tricky. Admittedly, there are some good books on computer vision, but since the community is moving so fast, any book you buy is invariably outdated by the time it's on your table, right? So books are useful to get the background, but often a little bit more, let's say, what you could call the more classical approaches. And but things have gotten a lot better nowadays. You can there's a lot of tutorials online. There's a lot of lectures. So, for example, all my lectures, you can find them on YouTube, right? And I know that they are extremely popular. People just go to them, click them, watch them, and so, and this is true for many of the lectures nowadays. So I think a good way to get into this whole field is tutorials and lectures that you can find publicly, um, either on YouTube or on some of the massive online course sites. And this works. And then, I think a lot of it is accessible also. As you said, publications are online, have been online as long as I can remember. So this is great to have, today with the internet, we have all of this knowledge at our fingertips. And Wikipedia often gives good introductory lectures to certain topics. So I think it's all there and accessible, and you don't even need to go to a library to get a solid computer vision and machine learning background.
Thank you. So this was my last question for today. Thank you again so much for participating in our podcast. It was really, really insightful. Really hope that maybe a year later, 2 years later, we will be able to meet again on our platform.
Yes, I hope so very much, and I certainly hope that at some point Corona is over so that we can
Yeah.
all meet in physically again, because this is something that the vision community is missing nowadays, is the capability, that the possibility to actually meet in person, because ultimately, despite the growth of the vision community, it's still a wonderful family.
Yeah. Thank you so
Thank
much.
you.